Dear all, myself Nishad, a grand welcome to Outens Edus Online. In this session, we are going to discuss about Mason's gain formula for finding overall transfer function. Okay, we can find the overall transfer function of a system T of S is equal to M. Here M stands for transfer function. That is equal to summation Pk del K by del, where this K is the number of forward path and Pk is the gain of kth forward path, and del is equal to 1 minus summation of Lj, where Lj is the loop gain of the jth loop, then plus summation of Li Lj. Li Lj is the gain product of ith and jth loop, minus summation of Li Lj Lk. This is the gain product of 3 loops. Suppose I have a system having 3 forward paths. So K is equal to 3. So P1, P2 and P3 represents the gain of first forward path, second forward path and third forward path. Suppose we have some 4 loops. Let that is denoted by L1, L2, L3 and L4. Where L1, L2, L3 and L4 are the loop gain of first, second, third and fourth loop. Now this time summation of Lj, that is equal to sum of all loop gains, that is L1 plus L2 plus L3 plus L4. Okay, this time that is summation of gain product of all possible combination of 2 non-touching loops. Suppose loop L1, L2 and L4 are non-touching loops. That means L1, L2 and L4 are non-touching loops. That means for these loops there is no common node or common branch. Okay. Now this term indicate L1, L2, that is the gain product of first and second loop, plus L1, L4, that is the gain product of first and fourth loop, plus L2, L4, that is the gain product of second and fourth loop. Now this minus summation of Li, Lj, Lk, that is the sum of gain product of all possible combinations of 3 non-touching loops. Okay, suppose these are non-touching loops. So this stands for L1, L2, L4. So we have only one term here. Then next term is, this is minus, then again plus, summation of gain product of all possible combination of 4 non-touching loops. And it goes on. Okay, I think the concept is clear. Now what is del K? Del K is same as del, but obtained by loops that not touching the kth forward path. That means suppose we have some loops that is not touching the kth forward path. So by making use of that loops, we can construct del K, right? Now based on this, we can do some problems. Now we have system. We want to find the transfer function of the system C of S by R of S. Okay. Now we can use Mason's gain formula. The options are given. So first I am going to draw the signal flow graph corresponding to this block diagram. Okay, let us draw. So now the summing point can be removed by a node. Then we have an output node. That is C of S is output and R of S is the input. Now I am drawing this. So in this path we have a gain of 1 by S plus 4. That is 1 by S plus 4. Now this summing point is removed by a node. Let this represent this node. So from here we have a path and the gain of the path is 1 by S plus 4. It is a feedback path having a gain of 1. So we can draw that path like this. The gain of this path is, this is a negative feedback, so minus 1. Okay, so this will represent the signal flow graph of this block diagram. A forward path is a path that connecting input and output in such a way that no node or branch repeats. Now our forward path is, we are starting from the input node and moving along this to the output node. So this is a forward path and there is no other forward path. So we can write our forward path is P1 and gain of our forward path is 1 divided by S plus 4. Now how many loops? Now I am starting from this point, moving along this direction and returning to this node. So this is a loop having the gain, loop gain, that is a product of path gain, that is 1 by S plus 4 into minus 1. So minus 1 by S plus 4. Now this is also a loop. I am starting from this node and moving in this direction. So that is the second loop and loop gain is equal to 1 by S plus 4 into minus 1. So we have two loops. So these two loops are touching loops. This loop is also touching this forward path. This loop also touching the forward path. So there is no non-touching loops. So by making use of Mason's gain formula, transfer function that is given by M, that is equal to C of S by R of S. And we have only one forward path. So P1 del 1 divided by del. Okay. Now we can find the value of del 1. Del 1 is equal to 1 minus sum of all individual loop gain. That is L1 plus L2 plus sum of gain product of all possible combination of two non-touching loops. But L1 and L2 are touching loops. There is a node in common. So we don't have any two non-touching loops. So this plus 0. This is actually minus. Okay. So the loop gain of this loop, that is equal to minus 1 by S plus 4 into minus 1. So this become plus 1 by S plus 4. So we can replace this by 1 by S plus 4. Now our del 1, that become del 1 is equal to 1 minus L1 plus L2. That is equal to 1 minus L1 is 1 by S plus 4. L2 is minus 1 by S plus 4. So this terms cancel, that becomes 0. So del 1 is equal to 1. Similarly, del is equal to 1. All the loops are touching the first forward path. So the value of del 1 is equal to 1 minus 0. That is equal to 1. So we get the answer is equal to P1 del 1. P1 is 1 by S plus 4 into 1. That is del 1. Divided by del, that is equal to 1. So answer is 1 divided by S plus 4. This is a transfer function of this system. So option is A, that is 1 by S plus 4. This is a previous year gauge question. We want to find the overall transfer function of the system and the options are given. So first we can convert this block diagram to signal flow graph. Then by making using Mason's gain formula, we can reach the solution. Okay. Now I am drawing the equivalent signal flow graph, replacing this summing point by a node. This summing point also by a node. And this is our input node. So we have this branch is drawn like this. This is our input R of S. This summing point is replaced by a node. Now I am drawing this path. So we have a path like this and gain of this path is 8. Now I am connecting this 8 to here. So I can draw like this. Here we get the output C of S. And gain of this path is also 8. Okay. So I can draw this as like this. And gain of plus 4. Since this is a positive feedback. And I have a feedback path like this. So that can be drawn like this. And gain is again 4 for this feedback path. Since that is a positive feedback. Now we can obtain our first forward path. I am starting from input node and moving along this direction and reach the output node C of S. So this is a forward path. This is denoted by P1. That is equal to 8. Then moving this direction and reach CS. That is also a forward path and gain is equal to 8. Is any other forward path? Yes, let us check. I am starting from this point and moving along this direction and moving this and again going to output in which no nodes are repeating. So P3 is the third forward path. The path is 8, 4 and 8. And our fourth forward path P4, that is equal to, I am moving along this direction and going through this direction and reaching here. So 8, 4, 8. 8, 4, 8 is also a forward path. Now there is any loop here. Let us consider. I am starting from this node and moving like this along this direction and moving like this and returning to the same node. So this is a loop. The loop gain L1, that is equal to 8 into 4 into 8 into 4. And we have only one loop. So using Mason's gain formula, gain M is equal to P1 del 1 plus P2 del 2 plus P3 del 3 plus P4 del 4 whole divided by del. Since we have only one loop, that loop is touching all the forward path. So the value of del 1, del 2, del 3 and del 4 is equal to 1. Then what is the value of del? Del is equal to 1 minus, we have only one loop, L1. Okay, so this is equal to 1 minus 8 into 4 into 8 into 4. That is equal to 32, 32 into 32. 1 minus 32 into 32. Okay, now we can find the overall transfer function. That is minus 16 divided by 31. So the option is C.